Hello, my name is Ugo, and I'm doing this discussion post to understand and match stages of umpire. What I'm a little confused about is how it's different than the understanding stage. Uh, Other than I guess you just add the matching to it. I feel like the matching is pretty small section because you just have to remember things that you've done in the past and associate them and how figure out how you would implement them into this solution. So um, I think I'm just gonna skip the understanding step because I already made a whole video about that right here. I'm just gonna continue off of the notes that I have currently. Um, so if you didn't see it, basically all we're doing here is we're trying to solve how much water can be trapped within heights of square blocks if it started raining. And I mean, it's pretty self-explanatory if there's like an opening or if it's flat or if there's like no sort of form of containment, there will not be water. So in this case, there's no container on the right, there's nothing on the left to stop it here, there's nothing here to stop it, so we don't put water there. But there is water here because it's between two solids that can stop it. We're provided a list, and the list represents the heights of solid blocks. The blocks are squares, same dimensions, and we just have to calculate how many water blocks there are. The example we give is this list, and the output should be this height, or this amount of water, I mean. And I mean, if you look at the diagram, it also shows that. The solution that I planned out in the understanding stage is just first a base case. If it's less than 3, then return 0. We create 4 variables, 2 of which are going to be pointers. So this is where I started matching. Because we need to have a way of knowing that there exists a spot, or that there exists solid blocks to the left and to the right of something. To know that, we need something that points to the left solid block and something that points to the right solid block. And with that information, all we need to do is figure out whether there exists a dip after the solid block. So I used what's usually called the 2-pointer method of using a left and a right, because we need to know whether there's a left and a right block in order for there to be possible water between them. So a problem or a situation I've seen this done in before, and in an easier problem, would be the palindrome, where you have a pointer to the left of a word. I'll just do A, B, C, B, A. You have a pointer pointing to the end, to the right and the left, and they'll converge at the middle, or they'll end up going inwards towards each other. And what this allows us to do is to check individually both sides and compare them. For a palindrome, these two that we're pointing to have to be exactly the same. If they are not, then we just return true. Otherwise, we just go through the entire thing until the left and the right overtake each other like we do here. Once that happens in a palindrome, you would have to return that it's true if it successfully did that. We're doing something like that, but rather than returning true if it goes all the way, is that we're returning the amount of water, and we just increase the water when there's a condition that satisfies that. There's nothing more, I think, that I could relate to previous problems other than that, the 2-pointer thing. I guess I have used max, and using max with subtracting allows you to check if something is less than, or if there exists a dip, I guess. So if the current one we're on has 1 block and the next one has 0, we could find the max between them, assign the max into one value, and then subtract that max that exists with the value at the next one. If that is a positive number, or no, if there's a number that is not 0, then there exists a dip, and that's the amount of water that can be stored there. If they are the same, which is the only other case, because the max will either assign the current height or the other height to be the max. And if the other height is bigger or equal to the current one, then subtracting it by itself will just get us a 0, and we won't add water, which is essentially what's happening here. Yeah, there's nothing more to it, honestly, that I've seen before this, and I don't want to waste your time explaining it again. But yeah, have a good day.